Hello, my dear math magicians. On this lovely day, we are going to be solving a system of linear equations by substitution. So, would you please do me a favor and consider this? If you were asked to solve the system by graphing, explain why it might not be the most simple option. And here is your system. So take a few moments to consider that and write your answer there. And now that we've considered that sometimes we get tedious results and that solving by graphing is not always the easiest, especially when we're doing so by hand. So let's look here. We're going to solve using going to use a method called substitution. So step 1, we're going to solve for one variable from one of the equations. Step 2, we're going to take that expression and we're going to plug it into the other equation and solve for the remaining variable. Then we're going to take the value from step 2 and plug it back into step 1, and we're going to solve for the second variable. All right, so let's do this. All right. Okay, step number 1 is actually done for us already. Why? Because y is solved for. Look, let's see here. See, y is right there, and so this expression is the value of y. So all we do is take that amount and we plug it right there into y. So that's actually step 2. So I'm going to rewrite this equation here, but instead of y, so you write 3x, you say minus 8 and times what? 6x plus 7. There we go. Now equals 4. So we substitute that expression in. Now all we need to do is the distributive property in order to get rid of those parentheses. So 3x minus 48x minus 56 equals 4. Now I'm going to do a couple things. I'm going to combine like terms here, so I get negative 45x. And then I'm going to add 56 to both sides to get 60. Now let's continue. Divide both sides by negative 45. And we get this, x equals negative 60 over 45, and that reduces to negative 4/3. All right, I don't really like that answer, but it's an answer. So let's see here what to do next. Step number 4 says substitute the value, this value, from number 2, and we're going to place it back into 1, which is actually just this yellow one up there. So let's do that. So y equals 6 times x, but instead of x, we're going to put the negative 4/3 there. Okay. Now what's nice is that things reduce here. 6 divided by 3 is 2, so we end up with this. Y equals negative 8 plus 7. And now we simplify that to get y equals negative 1. So what's my answer? Negative 4/3 and negative 1. Now all we have to do is test it. We're going to check it. So let's do it. I'm going to put both those numbers into both of these equations there. And so let's see what we get here. Over on the left side, I get negative 1, and of course that reduces there to be 2, so I get negative 8 plus 7, so negative 1 equals negative 1. So far, so good. And this one over here, the 3 is reduced to 1, so I'm left with negative 4, and this says plus 8. Does that equal 4? 4 equals 4, and we see that we have a check. Ka-chow. All right, now your turn. All you have to do is take this, and the hint I'll give you is that since x is already solved for, just take that and plug it in there. Ready, set, go. And the result here should be 8/2. Now let's take a gander. Here, we're going to do the same thing, but instead of having the grid with you, I'm just going to show you the process that we can do all together. So the very first step that we remember is we need to get one of the variables by itself. So which variable do we get by itself? Well, we have a couple options. The easiest is either this x or this y. Why? Because I don't have to divide by anything when I isolate that x or the y. So let's go ahead and let's see. So if I choose to get this x by itself, then what happens is this. Let me just rewrite it over there. I get x minus 2y equals negative 13. So I need to add 2y to both sides. Add 2y to both sides to get this. X equals 2y minus 13. Okay, so that's step one. Step number one, I isolated. So what's step two? I have to take this expression and plug it into there. Now, you don't need those arrows. The arrows might make it look ugly. So I'm going to clean that up real quick and just say, now step two. So I'm going to say 2, but instead of x, I'm going to put 2y minus 13 plus y equals negative 6. Now I distribute there to get 4y minus 26 plus 1y equals negative 6. I'm going to do two things at once. I'm going to combine like terms there to be 5y, and then I'm going to add the 26 to both sides to get 20. Notice now I get y equals 4 when I divide both sides by 5. So that's step 2. So let's follow along. Now step 3 says I need to take this expression and I'm going to plug it back right there. So notice here. Here's step 3. Just going to continue. So all I have to do is substitute x equals 2, but this time I'm going to plug in that 4 there, minus 13. So x is equal to 8 minus 13, and x equals negative 5. So what's the solution? We're claiming that the solution is negative 5, 4. So there are two ways to check it. We can plug in the negative 5 here, and the 4 here and here to make sure it works. But we can also check by graphing, so I'm going to do that real quick. And now when I graph this here, here's the x minus 2y equals negative 13. So there we go. And the 2x plus y equals negative 6, and negative 5, 4 is what we get. So good job. Go team. Now it's your turn. Walk through the process on this one. And the final result here is 4, negative 2. And there we go. All right, now let's take a gander at what happens when we have things that don't work out so nice and purty. So systems with infinitely many solutions or no solutions. So just as a quick review, remember we've got a couple options. If I had my grid here and I could have two lines and they intersect right here, so they have one solution. Although I could have two lines such that they never intersect like this. So this one has no solutions. And then lastly, if you have the two lines but turns out one on top of the other, you end up with the same line. This one was infinitely many solutions. Okay, so what does that look like in terms of solving algebraically? All right, so step 1 is already done for us. So I have the 3x minus 1, so I'm just going to plug it into there. So here's my 6x minus 2 times 3x plus 1 equals negative 2. So continue on. 6x minus 6x minus 2 equals negative 2. Notice that the 6x minus 6x is 0. So I'm left with negative 2 equals negative 2. Now this is true, but unhelpful. We already know that negative 2 is negative 2, but I don't know what x and y are. So as a result of this true statement, our conclusion is infinitely many solutions. Infinitely many solutions. All right, so what happens when we get no solutions? Well, let's take a gander over here. So process being almost the same, I'm going to step 1, I've already solved for. So step 2 is I'm going to substitute that in. So it looks like this, 5x minus, and I'm going to put it in parentheses, don't forget, equals negative 4. So when I do distribute that negative, I get this result here. Notice that 5x minus 5x is 0, and I end up with 4 is equal to negative 4, and that's actually false. That not only do I not find out what x and y are, I also come up with a false statement. So as a result of that, these two equations will never be true together. So as a result of that, this has no solution. No solution. So that's my conclusion. All right, now it's your turn to work through these ones. Ready, set, go. The last thing we're going to do is an application. So let's look here. In one day, the National Civil Rights Museum in Memphis, Tennessee admitted 321 adults and children and collected $1,590. The price of admission is $6 for adults and $4 for children. So how many adults and how many children were admitted to the museum that day? So the first unit is dollars, and the second unit is the number of adults and the number of children. And it actually doesn't matter which one we know. So in unit 1, if I'm thinking about dollars, I know that I have total is $1,590. And I know that adults cost a certain amount. Adults cost $6. And children cost $4. So if I call A the number of adults and C the number of children, notice what happens. When I take the $6 and multiply that by the number of adults, I get the dollar value of adults, how much adults spent. And when I take the $4 multiplied by children, that's the dollar value brought in by the children. And the total is going to be this. So it looks like this. $6 times the number of adults plus $4 times the number of children is equal to $1,590. So the same idea happens over here. But in this case, we're talking about number, just the total number of children and number of adults. Well, this one's a much more straightforward. If we just had the number of adults plus the number of children, it equals 321 is what it says right there. So it equals 321. Okay, now, how do we solve this? Well, I need to get one of these variables by itself. Well, if I try to get A by itself, I have to divide by 6 eventually. Here, I have to divide by 4. But either one of these, I don't have to divide at all. So, step 1 is I'm going to take the A plus C equals 321, and I'm going to solve for one of those values, and it doesn't matter which one. Now, step 2, I'm going to take that value, this expression right here, and I'm going to plug it into, not to there, but I'm going to plug it into C right there. So there we go. 6A plus 4 times 321 minus A equals 1590. Now I'm going to distribute out. So 6A plus 1284 minus 4A is equal to 1590. Running out of space there, so I'll continue it up there. So I get 2A is equal to 306, and A equals, and let's pause. Before we have this answer, we know what kinds of numbers to expect. Because this is a practical situation with practical application, we know that we're expecting a certain number of adults, positive number, and no decimals or fractions allowed. So the answer I get here, I'm expecting to be reasonable. So when I divide by 2, I get 153. So far it seems to be 153 adults. Okay, so that's step 2. Now step 3 is just to take that expression and plug that back into step 1. So 321 minus 153. And we'll get our final result here. 168. So far the answer seems to be this. There were 153 adult tickets and 168 children tickets. Now the check, all we have to do is check the price on things. So 6 times the adults plus $4 times the number of children should be $1,590. So let's plug that into our calculator. And in the end, I get 1590 equals 1590, so it does confirm. So let's commit to 153 adults and 168 children. Now it's your turn to attack, kill, destroy for the school play. Ready, set, go.